Look at it now. To sit next to you. All right, guys. So this is the picture. It's kind of like a yes, no. There's, I think, 4 different curves making this shape. There's this one, which is y equals x squared plus 1. There's the bottom, which is y equals 0. There's the stick that it's spinning around, which is x equals 0. And then the outside edge, which is x equals 1. So this is my shape. If I was doing area between the curves, would I be doing top minus bottom or right minus left?
Right minus left.
Well, yeah, actually, if I was doing area between the curves, it would be easier to do top minus bottom, but you're right that I'm on this one, that it's spinning this way. I have dy slices, so I need to do right minus left. Is the right-hand curve the same curve the whole time? Yeah, it's a straight line of x equals 1. Is the left-hand side the same each time? No. Actually, what's with the bottom? Is there any hole at all? Like, isn't it just a big fat cylinder with a radius of 1 and a height of 1? So if I do the right minus the left, pi from 0 to 1, by the way, that is going to end up just being pi, but we'll look at it more in a second. And then on the next one, from 1 to 2, is it one that I need to drill the hole out of, or can I do this distance minus the inside thing, and that's the radius? Which way does it go? Okay, let's look at a cross section of that this way. That distance was, the large radius was 1. This inside radius to this inside curve, and I need it as an x equals. The side on the right, is it a positive square root blah blah, a negative square root blah blah, or do I have to keep both? Positive only, because I'm on the positive sides. So that inside radius is square root of y minus 1. So is this a big radius squared minus little radius squared, or do I subtract those sticks and get the radius of the solid? Big radius squared, 1 squared, minus little radius squared, square root squared is that. Raise the power, divide by the new power, it's to the first. One minus negative 1 is 2. So this one is pi, and this one is pi. 4 minus 2 is 2, and minus 2 minus a half. So 3 halves pi?
I got 5/3 pi.
Okay. Do we agree the bottom is just a 1 pi cylinder volume? Yeah? Okay. So we can just look at the second half. So Amir, 1 minus y minus a negative 1. Do you agree with me that it inside the integral is 2 minus y? Or are we still struggling over how to get the radius?
Uh,
It's a little messy, I agree.
on the, I swear that, yeah.
What is the point of the first integral?
For those who don't see this as just a cylinder and don't know the volume of a cylinder, I can do it by integrating a circle times the height. That is where the volume of a cylinder is pi r squared, area of the cylinder, or area of the circle, times the height. If the radius doesn't change, you didn't have to do this. You needed to get the volume somehow, but you could have used the cylinder formula.
So could you just imagine the whole thing as one cylinder and then take out the radius of the?
Drill out the hole in the top. Yep. Which is the easiest way to do it, but I didn't want you to do it that way, and probably none of you did because. Okay.
And then why? Why do you have to get the 1? You just do it on the y-axis.
So, the second, sorry. The second one that you have is the Wasserman,
Yeah.
because
it's got a hole in it.
and then the one on the other side, the left one, is
Is
just the
this
cylinder.
solid? Okay, can I show you what Owen was suggesting to
Yeah,
do,
sure.
which is much easier? You prefer easier?
Yeah.
So Owen was saying, can we just find the whole cylinder? You want to do that using the volume formula of just the cylinder?
Pretty easy.
Seems pretty easy. So volume of a cylinder is pi r squared times the height. And in this case, the radius is 1 and the height is 2. So the volume of this entire cylinder, if it was solid and filled in, 2 pi. So Amir, this might be easier. Now we need to subtract the hole. There's a divot in this thing. Do you agree?
Yeah.
So the volume of the hole, where does the digging start? What is the height?
Pretty high is that 1?
And how deep is the hole? What's the tallest that the hole is?
1,
At y equals
2.
2, okay? And I'm digging out in a circular
So
fashion.
you just integrate y minus 1.
Okay, I need to figure out the radius. David, what is the equation for the radius? Because the radius changes. Here it was 0, then it became like 1/4 and 1/2 until we got to 1. So first question though is, do I need y equals x squared plus 1, or do I need x equals blah, blah, blah?
X equals.
X equals. So subtract the 1 and do the square root. I get plus or minus. This is on the positive side. So Amir, do you agree this is my radius of the hole that we're
Yes.
digging? All right. So the area formula of the circle is pi. That guy squared.
Exactly.
So yes, we're now just integrating to find the whole. Raise the power, divide by the new power. So Addison, is this working?
My question was, why'd you add 1 squared minus y minus 1 in the last part?
Well, that was part of when it was a more complicated question. Right now, we're just doing the volume of the hole and subtracting the hole out of it, rather than doing the big radius minus the little radius. Sorry, big radius squared minus little radius squared.
There was no big radius. There was no little radius.
Okay. Plugging in 2, that's 2 minus, 4 squared over 2 minus 2. What do we get when we plug these things in?
radius.
So we need to subtract out 1/2 pi, so we get the same answer?
That makes
That-
sense.
Okay, so Amir, this doesn't always work though, because, yeah, just because things get more evil. Try drawing the picture.
The region.
Oh, that the line.
Okay, so here's our picture. How many lines does it have to touch? 3? Which 3?
0 and 1.
2x, 0, and x equals 1. Okay, so that's red, blue, and green here. But it's spinning around this guy, right? So the other side of this losing the edge there, too many lines. Yeah. Okay, so it's this funny looking solid with triangle-y things in a volcano. Yes, thank you, volcano. So this stuff rotated to here. What is the, okay, is it a solid or does it have a hole that was drilled out? There's a hole. What is the radius of the big outside thing? That one, you said what? Okay, which way does this go? So x equals y over 2, because first of all, I need it with the equation with y's in it, because this is a dy slice. And there's two radiuses, so the outside radius squared minus the inside radius squared. Integrate from pi 0 to 2. Like, those things hopefully are quick and easy to set up and understandable, and if they're not, let me know. Okay, that large radius, this stick. How did, clear?
1 plus 2.
1 plus 2y, how are you?
Or 1.
I need things as y's. So the equation of this line is y over 2. That is this distance. This equation gives me the distance that x is from the y-axis. So what?
2 minus y over 2.
So I need the anti of that. Isabella's saying 2 minus that, because this distance 2 is constant the whole time. 2, 2, 2. Now I'm going, this bit is 2 minus that y over 2. Okay? All right. Nick, what is the inside radius?
1.
The whole time it doesn't change at all?
Yes.
Doesn't change at all. Madison, you're still unhappy. Okay, finding any radius or both radiuses? Okay. So Addison, let's try this. What is the length of that stick between the purple and the green line? 1, do you agree that's the inside radius? Because this is gonna make a cylinder in here. The radius is just 1. This is what we're rotating around.
Okay.
All right. Find the outside radius. Outside radius, this length.
Yes. Oh, and it's changing, so that's why it has y.
Correct.
The other one isn't changing, so it's just y.
Yes. So this distance is 2, and I need to subtract that guy. What is the length of, what is that? The distance from this line to the y-axis is that equation. Anybody get an answer?
Oh, it's that. Oh.
So I integrated by raising the power, dividing by the negative power, and dividing by the derivative of the stuff inside. Am I allowed to do that? I told you guys the last couple days, no, I don't do that.
Yes.
Because the derivative of the stuff inside is -1/2. Just a number. So dividing by -1/2 is multiplying by -2. So I get pi, plug it into, that's 1 cubed is 1, so -2/3 minus 1. Now plugging in 0 does not give me a 0. Plugging in 0, that bit here goes away, but that's 2 cubed, which is 8, times -2, which is -16. Oops. I didn't integrate the second part. You guys can stop me. 1 integrated is y, so this is not a 1, it's a 2. -8/3 plus 16/3. 8/3 pi.
Yeah.
Okay.
I'm bad at this.
Amir, I have been struggling with arithmetic today, so we're good.
For the other problem, you set up 2 integrals. Like, how do you know when you're supposed to do that, when it's not that?
Okay, the other, the one that was kind of a candlestick thing.
Yeah.
If I asked you to find the area between these two curves doing right minus left, the right equation was the right side the whole time. The left changed from this one to being the stick. So that's what we, like, if the right side and the left side are the same equation the whole time, you're good. If they change, you're gonna need more than one integral. So, and now that I've said that, I also need to warn you about, if I make you integrate this way, this was on the sample quiz, this right side and that left side, this is x equals the positive square root, this side is x equals negative the square root. So it's y equals x squared, and I make it go that way. Okay. You guys allergic? Yeah, cool, great. Four, wait.
Do I get the drum?
Oh, the other one's gone now. Try setting up all 4 of these.
Oh, gosh.
Talk to the person next to you.
Do I get the drum picture?
There's a whole bunch of pictures.
I love
Yes.
drawing
You
pictures.
can't figure out these shape of it for the last of you. Can you should you give up or should you waste more time trying to figure it out?
Okay.
Okay.
I mean, not waste, but like, try to solve.
Solving, you should not completely punt on it. So Alessandra, you're effectively saying, should I just like take my 50% on the test?
No, but like, I was thinking.
I would do
I don't know.
So, can you draw these 3 curves for this problem?
I was just talking in general.
Do I risk?
So, the 3 curves together, what is it gonna look like? How do we graph square root of x? Okay, so it's gonna go like this. How do I graph y equals 2? Okay. So if y equals 2, what's the coordinate where those two meet? If y is 2, x is 4, so this is the coordinate 4, 2. And then our other curve is x equals 0. And so they intersect down here at 0, 0. So there's the shape. And A, B, C, and D are going to make wildly different images. So, but you're okay with the cross section? So that rotated around the x-axis, reflected. And here goes my crack 9th grade art skills. I'm gonna make this, it's like a big empty bowl with a
You can make that one a little rectangular prism and then take out.
Okay. I thought you were saying like the shape is like.
So it's
You can.
that guy rotated around. So when I add an extra line to it, it looks kind of like not good.
Cylinder, God, it's a cylinder and you take out the hole.
Just integrate x from 0 to 4 and multiply by 5. 4 pi.
All right, Thunder, what's the B gonna look like? It's gonna be that shape.
It's kind of like
Rotate it this way. What is it gonna look like? Like a whirlpool-ish thing, right?
that's great.
It's a swoopy cone. It's not an actual cone. Yeah. Okay. All right.
You find the
Okay,
volume.
Actually, so I don't know if you noticed.
Around y equals 2. Okay. So
Find
y
y
equals
at
2.
the side integral having the region bounded by y equals spin to the base, the y equals x equals to the x-axis to the x to like y equals to the line x equals 4.
All right. So now this one is rotating around
I probably should
y
have told you
equals
that
2.
earlier. No. So it's like the other way.
So around y equals 2. Copy the
Maybe
footprint
the same volume.
and do the spin. So it's kind of like a
Oh, same
triangle.
volume.
This is freaking.
Why?
No. This one's much different. That
Um.
one just has like a little.
It's freaking crazy.
This one has most of it.
All right. D. D.
What's D?
D is a good time.
Oh,
Wait,
X and y axis.
this looks so cool.
Nice shape.
Okay, so it's like similar to A, but
But this way. Artists are welcome to take over and draw for me. But, so, if you can get the picture, like, get the footprint. By the footprint, I mean, do that. And then, whatever stick you're rotating around, make a reflection. Sometimes the reflection's gonna create a hole. Like here, this got reflected to this side, there's a hole. This one, when it got reflected over y equals 2, this stuff it was a solid. So there are 2 solids and there are 2 things with holes. There are 2 dx's and there's 2 dy's. Try these. Work with the person next to you. So Alessandra, no, don't just punt.
You have to find the point.
Yeah, now you gotta find volume. You gotta find the radius or
What if
radius.
I said?
Okay.
I would.
If you choose,
50%.
yeah, if you choose to be like, if I say solve for X and you're like, no,
No.
you're like, give me credit, no.
No? Okay, fair enough.
I would answer.
Because one of them is on the other center.
It's not gonna what?
I would say
Which one?
A and C.
my question
What do you mean how Like, if I did,
it's this.
no, if I do this, make a shape like that, a different volume of a shape like that. Like a cone and that are not the same one.
My bad, kid. Sorry, kid.
Like if I take the cone out of the side,
The first one I just integrated.
so the remaining thing.
X to the power
I'm so confused.
of 1/2.
Okay.
Because this is just this shit.
But they're rotating very different.
0 to 4 and then multiply by 5.
Let's see.
not big.
I think E and C are the same color,
It's a
right?
little more complicated.
And A and C are not the same.
Not the same at all.
Not the same.
They have a similar look.
But very different colors.
Yeah.
That sounds about right.
This way.
No. I got a similar.
Our equations are square root of x and
So it's 2.
it's not letting me set bounds.
So it's just. I don't know. Why are you smiling? It is D.
Equals-
I freaking hate these.
They speak well of you.
They do. First, I'm just gonna make it a prism. It's a cylinder.
It's the outer radius minus the inner radius, right? So it's square.
So it's got a radius of 2, pi, 2 squared. Is 4. How is that? Bro, you tripping.
I don't think the radius is
So, Jacob, I'm not sure this is helping visualize, but that's part A. Is there's like an Easter egg butt print. Yeah. How do I make it rotate around x equals 4 in this equation?
You would have
The other one was to be rotated around y equals 2, not the x-axis. So let's see.
No, I mean like this is.
About rotations of that.
Also, that would give you.
I'm trying to. Don't see how it's going to let me change that.
Oh, you could probably divide them into.
Well, I don't like that. I like right to left.
What if?
All right.
Okay, outside function is
Yeah, you have to square the radius.
square root of x,
Square that.
and the inside function
B time.
is y equals 2.
My axis. Well, that one is. Yeah, so you have to.
That probably could work.
Or can you?
You should do it. And then see if you can say
Cut out this green.
I can solve this by doing.
Yep.
Where is there a wall?
For the small radius, are you allowed to like boil it, or do you have to
You can.
reverse power? If you were to reverse power rule, the derivative for this of the parentheses is negative 1/2.
That's like,
So
yeah.
expanded.
You should take it out twice, bro. I'm a genius. Why?
Okay, I'm attempting to show what it looks like for part B, I think. There's our cross section, and this is it spun around y equals 2. Looks kind of trumpety. The RCA funnel thing. Witch hat, I don't know. Pick your favorite descriptor. wizard hat, okay? So again, that's, this thing rotated around y equals 2. And had another one.
I'm integrating with dx this time.
And this is part A.
So it'd be 16.
64.
What? Okay.
4 to the 3 halves is 8.
What?
Yeah, it is 8. Derivative is 2.
Part A. So part A is, it's a cylinder with, you know, the little eggs for Easter that you get, the plastic eggs? It's like a cylinder with the egg drilled, the egg part is drilled out.
Oh, okay.
It's not a great imaging system, but you see the egg? Half an egg. Woo!
You gotta try this again.
Okay. This is really fun. I'm confused about A. Isn't it 5 times the big radius?
Big radius.
Never mind, I'm not confused.
Is 2.
Yeah.
Little radius is square root of x.
So you square it and it just becomes 4
So
and x.
integrating I from 0 to 4.
Yeah.
Big radius squared minus little radius squared.
Gotcha. I see.
Do we agree this is the setup for part A? Big radius is 2. Little radius is square root of x. Big radius squared minus little radius squared is just drilling a hole out.
I'm doing my silly.
That's true.
Okay. This one you can. Because R is 2. If R was something more complicated,
I just did it all.
well, you don't need to do that here. This one we need y, so this is x equals y squared.
Okay.
So we're doing right minus left. Well, there is no left. That's squared.
Yeah, I did.
Pi and 0 to 2.
What'd you
Yes.
pi over
I made
nine.
the cylinder and then I took out the part.
I got a
It's not in there.
Okay. Well, but that just means you did a cylinder for no reason, because all you need to know is the part that's
It'd be,
the solid.
it would be.
But
it would be
go you,
five.
feel free.
Yeah.
Okay, that makes me think.
And
Part C, do I need 2 radiuses or is it just 1?
Just one.
Just 1. What is this distance?
2 minus square root.
Yes. And pi that squared dx from 0 to 4. Anyone got the craziness of part D?
It's gonna be pi
Cylinder method
times
not super efficient.
from 0 to
Outside radius, what is the big radius?
that big radius is
4.
this.
So this one you can do your cylinder thing because R is just 4. Okay, inside radius, this is the hardest one on here. What is the inside radius that we're
4 minus root x.
4 minus root x? Are we y squared or root x? Do we want the equation in terms of?
Y squared.
There you go. So big radius squared minus little radius squared
And then it's from 0 to 2.
from the y values 0 to 2. Get your pi on there.
Could you do
Gotcha.
calculate that?
I understand.
Take away
Yes, so, Owen, this is a good one to say, that outside shape is just
Cylinder.
4 pi squared times another 2, so 16 pi squared, and then just grill out the whole.
Cylinder.
I always like every day.
Because it's so shit.
I don't think
I think about it too. Instead of the 7 curves, it's 2 curves
Which way?
that intersect each other.
What's the thickness?
Yeah, I really
That